Okay, so recording. So let's get started. I am going to pull up, I'm going to share my screen with you. So I'm going to stop my video now that I'm done with my funny story. Sharing screen, we're going to look at 12.2. Okay. So you should be able to see my notebook paper screen. What is going on? Why is it yelling at me? I don't know. You should be able to see my notebook paper screen now. So 12.2, guys, is where we're going to go. So in 12.1, remember, we learned a lot about what the first derivative can tell us about a function. So I'm going to draw a picture, actually. Let me get a graph on here. I'm going to draw a graph. We're going to talk about what we learned about the first derivative and what it's telling us about our graph. And then we will talk about what we're going to learn in 12.2, which is how to take and interpret the second derivative. So let me give us function. Okay. All right. So we've got a function here. Okay, in blue, I am going to notate what we learned about the first derivative. So everything first derivative tells us. Remember, we could set the first derivative equal to 0.
Your screen is off.
It's just off?
Yeah, I can't see it either.
No. Okay. Let me try again. Okay, can you see it now?
Yes, ma'am.
Okay, perfect. Okay, so you can see my function that I've drawn here. Remember, if you set the first derivative equal to 0 and you solve for x, remember that's where you get the locations of these points, the highs and lows. We call these critical points. They're where the graph changes direction. We also found out that if your first derivative is positive, it means that your graph is increasing, like in this section here. In this section here, we found that our first derivative was negative, and then over here it would have been positive again because it was increasing again. So that's what the first derivative tells us, and that's a lot of good information. But we're going to talk about the second derivative today. So before I show you how to find the second derivative, and we will find multiple second derivatives today, I want to show you what it tells you from a picture. So what the second derivative doesn't tell you is where it's increasing or decreasing. That's the first derivative's job. What the second derivative tells you is about how it's increasing or decreasing. So the way I like to think about it, the first derivative is describing, this is how the function is changing. Like, is it going up or down? The second derivative describes how it is changing, how the change is changing, or the change of the change. You know, any way you want to see it, we're getting more detailed in being able to describe how the function changes with the second derivative. So let me draw in blue what the second derivative is telling us. So this first little blue curve that I'm drawing, notice it's in an area where my graph is increasing. So I know the first derivative is positive there, but you guys, the second derivative here would actually be negative. So it's all about, second derivative is all about shape. And notice this shape is what we call concave down. This area of the graph has a concave down shape, and the down part is how I know the second derivative here is negative. Let me talk about what concave down means. So let's look at multiple points on this function. So notice we're increasing from this point to this point, and it's pretty fast, right? I mean, it's a pretty steep incline. From this point to this point, it looks like it's still pretty fast, maybe not as fast though. And you guys, look at the increase from this point to this point. If I were to think about this as just the slope between these 2 points, it wouldn't be as high as it was down here. So we are increasing, but our rate of increase is decreasing. We're increasing at a decreasing rate. Think about the difference between these 2 points. Yes, it's still going up, but barely. So if your increase is getting slower, so if you're increasing, but it's at a decreasing rate as you go, you get this particular shape. We call it concave down. Usually I think about concave down as like, I don't know, like I always think it looks like a rainbow or an upside down bowl. You know, anything you want to call that, or like a mountain maybe, or like a little hill. So we have that. You guys, let me show you another part on this graph where we are increasing still, but it has a different increasing shape. Look over here. You guys, this part of the graph is increasing. We know the first derivative is positive. You guys, the second derivative is also going to be positive here because this part has a shape that we call concave up. So you guys, think about an actual bowl that's right side up. We're taking this shape. This is concave up. Oh, positive, guys. It's concave up. The second derivative, if we evaluated it over in this area, would be positive. Let's talk about what concave up means. So let's pick some points. So yeah, we're increasing, but how are we increasing? And how is that increase changing over time? So from here to here, you guys, from this point to this point, we're increasing modestly. You guys, this doesn't have a very steep slope here. You guys, from here to here, notice we're increasing faster. And you guys, what about from this point to this point? You guys, that's a really fast increase. And it just keeps getting faster. You guys, as you go up, this line is looking more and more like it's just straight up. So you guys, that increase is increasing at an increasing rate. And you guys, that's where you get that concave up, that bowl shape. You guys, the bowl shape is what we want. If you want your function or whatever you're modeling to be going up and you want it to continue going up, you're looking for a concave up area where both the first derivative and the second derivative are positive. Let's check this area down here. You guys, so notice, and there is going to be a change point. Because look, at this decreasing interval, let's talk about the concavity here. Look, this looks like a concave down place, right? So the second derivative would be negative. But you guys, this part of the interval is concave up. So I would say the second derivative there would be positive. So it works on the decrease too. You guys, in this area, the first derivative's negative the whole way. It's decreasing in this whole section, but the second derivative changes. It starts with a concave down section, but it ends with a concave up. There is a point here where it changes from one to the other. And that is an important point for us called an inflection point. So remember how critical points are where the first derivative equals 0? It's these. So all we had to do was we take the first derivative, set it equal to 0, and we find the location of those critical points. You guys, the inflection point is where the second derivative equals 0. I can find where it changes from concave down to up or up to down, and that is what the second derivative tells me. So I know my picture now looks super crazy because it's got a lot of drawings on it, but you guys, it's all about the fine tuning. You guys, I don't want to just know if my graph is increasing. I want to know how it's increasing. Let me show you a good example why this might be important. It's all about trending, right? Like, let's say you're analyzing stocks and you have this stock price and you have past data from it. And you've used that past data to model it by a function. Let me give you two cases. So you're looking at this stock and you've modeled it, guys. And it kind of looks like this. All right. Now, notice this graph, this little function that I just made up, it's increasing the whole way. It looks pretty flat here, but it's still going up slightly as it goes. So you'd say, oh, well, that's just growing. That's a good thing, right? Well, here's the thing. It's all about where you're looking. Let's say you're in this section. Maybe it's right about here. And you're making a decision. Should I invest in this or should I not? Well, take some derivatives. What you're going to find is that this area is a concave up section, which means, yeah, it's increasing and it's going to increase even faster and faster as I go. Look, it's getting faster. It's moving up faster. That's a great place for me to get in. You guys, I'm going to make some money because I have this second derivative that's positive here and it's concave up. But you guys, I got to be careful because look what's coming. You guys, we're coming up to a section where the second derivative would be negative, where it's concave down. And you guys, this is a bad place to get in. Anywhere past where it changes, which we'll talk about. But you guys, after it changes from concave up to concave down, this is not something you want to invest in because while it's still increasing, the rate of increase is getting slower and slower. You guys, that is a very good predictor that it might start decreasing. That's not what I want. That's not what anybody wants, right? You guys, so if I could find that inflection point, you know when to get in and you know when to get out. You guys, take it here before it starts losing money. How do I find the inflection point? I set the second derivative equal to 0. I can find this value. Now, in application, so if this was actually an application, you were actually looking at a real world company or stock or whatever it is, you guys, we could call this a point of diminishing returns. So a point of diminishing returns, basically what it says is past this point, it's not worth it to invest. You're not going to get the return you're looking for because while it may continue to go up a little bit, each time it goes up, it's going to be a little bit less of an increase until, and you don't know for sure. You never know for sure, right? You can't actually predict the future. But if the increase is slowing, there's a good chance it'll either just level off or go back down at a point. So this is important for us to know sometimes, and it's just an inflection point where the second derivative equals 0. So let's learn how to take the second derivative. I mean, if it's, you know, so important, I haven't showed you how to take it yet. All right, so let's start with f of x, just a regular old power function. I'm going to do 5x to the 6th plus 2x to the 4th minus 3x plus 8. So this is our starting function. To take the second derivative, I have to first take the first derivative. You guys, you can't go from original straight to second derivative. You have to take the first derivative first. So let's start there. First derivative is going to be 30x to the 5th plus 8x cubed minus 3. Now, to get to the second derivative, I just take the derivative again. I take the derivative of the first derivative. So just do it again. 30 times 5 is 150, x to the 4th plus 24x squared You guys, that is the second derivative. So notice how I know it's the, no, there we go. How I know it's the second is because it has two little tick marks or apostrophes or whatever you want to call that. That is one way to signify that we're in the second derivative. If you had the y as your original, it would just look like this. You guys, second derivative with the two marks. In fraction form, remember how the dy dx was a way that we asked for the first derivative? It wasn't as common. We don't use it as much, but it's a way to write it. You guys, this is how we asked for the first derivative. If we want the second derivative in that same notation, it would look like this. It would just have some 2's in there. So if you ever see this, this is second derivative also. I know this sounds really silly, but when I was, something that always solidified what it means to take the second derivative for me was like, say you've got f of x, and then f of x has a baby, which is the derivative, and then the second derivative is the derivative's baby, so it's like the grandbaby. And I know that sounds stupid, but just pretend that it's very smart, and I don't know, it just helped me remember. Some teacher, when they said that to me, and like it stuck, like it really stuck. You guys, this is the grand derivative, because you can't have a grandbaby without having a baby first. But anyway, guys, back to math, right? So the thing about derivatives is that they don't even stop at the second derivative. I could take the derivative again and have a third derivative and a fourth derivative and a fifth. You guys, they could go on forever, and sometimes they do. But we like to stop at the second because that's where we get the information we're looking for. Once you get past the second derivative, the information is not as applicable in most situations. So we're going to stop at the second for our problems. So let's see, let's do some more. So this was basic power rule. You just keep doing the power rule. That's too easy, right? Let's do something different. Let's do f of x equals the natural log of x plus 5. So let's take the first derivative. So let's remember how to take the derivative of natural log. We have natural log of something. To take the derivative, you put 1 over that thing. And yes, we do have to consider chain rule, where we multiply on the end the derivative of this. But you guys, the derivative of that's just 1. So it really is just 1 over x plus 5. But remember, I need to find the second derivative. So to find the second derivative, I have to take the derivative of this. Well, there's a couple ways I could do this, guys. You can see that it's a quotient, so your first thought might be quotient rule. I would not go that route. You guys, because it's just a 1 over, could I just rewrite this as x plus 5 to the negative 1? This is what I would do in this case. Just rewrite it. So remember, and we haven't had to do this that much, but just remember, if you have 1 over something, like we had 1 over x before, and we rewrote it as x to the negative 1, that's what I'm doing here. So if I have x plus 5 to the negative 1, and I have to take the derivative of that, well, use the power rule. Negative 1 comes in the front, then you have x plus 5 to the negative 2. Yes, again, try the chain rule, but the derivative of this is just 1, so it doesn't really change much. So I get negative 1 times x plus 5 to the negative 2. Here's my second derivative. So you'll find that when you get past just doing power rule, like with the power rule, you do the power rule on all the derivatives down. You just keep doing that. But like we started with natural log. We took the first derivative, but then when we took the derivative again, it wasn't natural log at all. It was something totally different. So you never know, you guys, it depends on what you start with, but you can't just assume, well, I used the natural log rule the first time, so I've got to use that again. Well, no, there's no natural log in this problem anymore. So So I had to use, you can use multiple methods as you go down. Let's see. What if my original function is 5e to the 3x? And I want to get to the second derivative, which means I need to do the first one. So you guys, let's remember exponential rules. The 5 is a coefficient, so it just comes down. E to the 3x comes down exactly as is. And then I'll do some chain rule with this term. So the derivative of 3x is 3. So you can put the 5 and 3 together and get 15 e to the 3x. So that's the first derivative. But if you want the second, you got to take it again. So let's do it again, you guys, from this line. The 15 is a coefficient, so it comes down. The e to the 3x comes down as is. Again, you do some chain rule. Now I'm at 45 e to the 3x. And there's your second derivative. So you guys, this is an example where because you have the exponential term, and remember it always comes down as is, you could take the third, fourth, fifth, sixth, seventh. You could take 100 derivatives here, and all of them are still going to have an e to the 3x in it. What's changing would be what's around it. But again, we stop at 2 because 2 is where we get the most information. Let me see. What do I want to do? So you guys, basically in this class, I wanted to explain, like with the picture, what the second derivative is telling us, how to find it in multiple cases, and next time we're going to be using it in applications. So, like that point of diminishing returns that I mentioned, we're going to find that in an actual problem. We're also going to be, so 12.1, remember we found critical points. We could say if they were a min or a max. We found increase, decrease intervals, all that kind of stuff, right? We're going to be doing some of that, but using the second derivative, which you're going to find out makes it easier for us, but that's not what we're doing today. Today is all about introduction to the second derivative. So I think I've introduced it pretty well, and how to find it. You got to find the grandbaby derivative, and I'm going to put in, so you guys, for 12.2, there's going to be a homework part 1 and a part 2. In part 1, you're just going to be taking second derivatives. And that's going to be put up here shortly. And that will be due on Sunday night with this week's homework. So that'll be on this week's homework. But part 2, since we're not going to start it till Friday, so this is stuff we'll learn on Friday. And it'll be due next week. I don't like to give you new stuff on Friday and make you finish it by Sunday. I think that's a quick turnaround. But you will have the part 1. And remember, on Sunday also, you have the 12.1. So you'll have 2 homeworks for this week, and then we'll split that up and put the rest on next week. But your homeworks for part 1, you guys, I'm going to give you all kinds of functions. You guys, maybe they're exponential, maybe they're natural log. I could put some product rule in there or some quotient rule. You guys, I shouldn't have to worry about your ability to take all kinds of derivatives at this point. So just because you have to take it twice, it shouldn't be a big deal, guys. I should be able to throw any type of derivative at you here in this part 1. And you just have to decide what to use when. So don't be surprised if there's some that, you really have to work at. Not really work at, but they might take a little more time, especially if there's like product rule or something in there. But yeah, it's going to be very eclectic in the type of derivatives that you have to take. Before we cut off, you guys, taking the second derivative, that's one thing. But after you take it, sometimes I'm going to give you problems where you have to put a number in. So like once you get the second derivative, it shouldn't be that much of a stretch to put a number into the second derivative. So for example, let's go like this one right here, guys. You guys, you found the second derivative. What if I asked for the second derivative at 2? Well, you know what to do here, right? You just put 2 in for the x's into the second derivative line. I'm not actually going to work that one out because those are big numbers, but that's what it means by that. So you will have somewhere you take the second derivative and then you put a number in there. But yeah, so get good at it, guys. Get good at taking the second derivative, and then I'll show you how we use it on Friday. So Friday, guys, while we're talking about Friday, you know, we're having low in-person attendance, and I want to be there and I want you to be there whenever it's possible. You guys, I want you to get that day in with me in person. I mean, I always feel so terrible as it is because we can't be in person every class. You know, it's just not the way it can happen right now. So you guys, Friday, if you like being in class in person, if you like to have that option, get there. You guys, you know, if you're sick or, you know, if something's going on, like if you've got COVID or something like that, or you're quarantined, I understand that you can't be here. But if you can be here, please be here, because I'm going to use it as in my decision-making process. You guys, I want to see how many people really, really, really want to stay in person on Fridays. If Zooming in is great for you, I really don't mind. That's great. You know, it makes me happy that you're getting enough out of virtual class, you know, and it makes me feel better that we have to do virtual class so much. But if there's just something that you like to get out of being in person and you want to keep it that way, you guys really show up for me on Friday so I know. And if you don't, then you don't. And then I'll probably stop going in person. You know, it's really just, you have to make a personal choice here and let me know about it. You know, show up, you know, say, I am in class, bud, and you cannot go to Weston's house right now. Because I'm in class. Sorry. I just want to know. You guys, I want to get a feel for it. If you're one of those who's like, it doesn't really matter either way, let me know that. You know, that's a good piece of information to have. But if it does matter, you know, be there on Friday, you know, let me know. Let me know it matters. If you can't be there on Friday for some reason, but it still really matters to you to be in person, let me know that so I can make a good decision. Honestly, I'm super worried because I've had multiple people, and luckily we don't meet in class that much anyway. So as far as like COVID stuff goes, it's not as big of a deal. But I've had people, you know, emailing, notifying, you know, I've tested positive, this and that. I'm kind of afraid we're going to have to go virtual for a while anyway. You know, I just don't want to make that decision unless it's totally necessary. So just let me know. That's all. I just want to hear from you. You know, if you have a strong opinion either way, let me know that. Be here on Friday, and then we'll go from there. Okay. Other than that, and that's it, you guys. So you'll have 2 homeworks due on Sunday. So you can start working on those anytime, and then I'll see you on Friday in one way or another.